Let's see some more example on this. How many bit strings of length 8 either begin with 1 or end with 20? So here we want to create a 8-bit string which is always begin with 1 or end with 0. So here OR is there. So two different type of system. One is always begin with 1 and second is always ending with the 20. So A is a system 8-bit string starting with 1. So how many 8-bit string starting with 1 can be possible is equal to cardinality of system A is equal to 1 is 2 raised to 7 because 1 is constant. First element from the 8-bit string is always constant, that is 1. So we have a 7 element which we can arrange in different ways. So that 7 element we can arrange in 2 raised to 7 ways. B is equal to second system which says that 8-bit string starting with 00. So cardinality of such system is that is 8-bit string ending with 0 is 2 raised to 6 because two last bits are fixed and bit we can change. So 2 raised to 6. Now number of bit string begin with 1 and end with 0 means it contain both. So it's a 2 raised to 5 because first bit is 1 and last two bits are 0. So in between bits are 5, so that we can combination of that will be 2 raised to 5. So total number of 8-bit strings starting with 1 or ending with 0 is. So how many total number of strings starting with 1 or ending with 0? So below we seen that total number of 8-bit string starting with 1 is 2 raised to 7. That's why 2 raised to 7 plus total number of string ending with 00 is a 2 raised to 6. So minus total number of strings starting with 1 or ending with 00 will be minus 2 raised to 5 because some string may be start with the 1 and end with the 00 and that possibility is 2 raised to 5. Therefore we have to minus that from addition of these two. This is a sum rule. So this theorem is called as a inclusion-exclusion principle. So cardinality of A union B is equal to cardinality of A plus cardinality of B minus common element, that is A cardinality of A intersection B. I will see next concept, that is permutation with non-distinguishable object. Means in permutation, if some object is repeated in a set, in that case what to do? So the number of different permutation of an object where there are n1 non-distinguishable object of type 1 and 2 non-distinguishable object of type 2, likewise dash nk non-distinguishable object of type k. In that case, permutation of that means arrangement of this set will be obtained by formula n factorial divided by n1 factorial into n2 factorial dash up to nk factorial. Means in given set of atom, sub-atoms are repeated. So in that case, suppose atom number 1 means type of atom 1, type 1 atom is repeated n1 times, type 2 atom is repeated n2 times, and type likewise nk atoms is repeated, type k atom is repeated nk times. So in that case permutation will be changed. So total number of atoms, that is n factorial, divided by type 1 atoms, how many times here repeatedly, that is n1 factorial, into n2 factorial, type 2 atoms repeated how many times, that is n2 factorial, and likewise n2 factorial. That is Cn comma n1, Cn n minus n1 comma n2, Cn n1 comma n2 up to nk minus nk. So n1 plus n2 plus dash plus nk is equal to n. Some example: how many different strings can be made by recording the letters of the word? So if you see the first letter here, F is repeated 2 times, means type 1 is repeated 2 times. Second string, if you see, there is no any repetition. So how many different strings can be made by reordering the letters of the word? So it is a problem of permutation. So here use a formula of repeated object. Total number of atoms are 3, that is n value is 3, but out of this one letter is repeated twice. So 3 factorial divided by 2 factorial is equal to 3. So there are 3 different ways to arrange this or reorder this word, the letters of the word. So and answer is 3. So these are the 3 different ways: O double F, F double F O, F O. Now second example, there is no repetition, so it will we can see this reordering of the letters by formula, that is nothing but n factorial. Here there is no any repetition, so n factorial is the answer. So 3 factorial, so it will be 3 into 2 into 1, that is 6. So 6 different ways we can arrange letter or reorder the letters of the string 1. So these are the different ways: 1, O E N, N E O, N O E, E N O, and E O N. So this is for your assignment. So in this case, see how many different strings can be made by reordering the letters of the words. So if you see this string or word, that is success, in this C is repeated 2 times, again S letter is repeated 2 times. So as per the formula, number of way to reordering the letters of the word to form a different string, you will get total number of atoms or letters in this string is 7. So 7 factorial divided by 2 factorial, because C is repeated twice and S is repeated twice, 2 factorial into 2 factorials. So it will give you total number of strings or can be possible from this string. Generating permutation. So we can use lexicographic methods to generate permutation for this string. Alpha is equal to S1, S2, S3 up to SP, and beta is T1, T2, T3 dash TQ, taken from the set 1, 2, 3 up to n. We write alpha is lesser than beta. Alpha is lexicographically less than beta, provided that star P less than Q and SI is equal to TI, for I is greater than equal to 1 and lesser than is equal to Q. For the following, suppose combination from the set F 1, 2, 3, 4, 5, 6, 7, set having these elements. Find the combination that immediately follows them in lexicographic order. So here you can see that 1, 2, 3, 4 is followed by 3, 4, 6, 7 is followed by 4, 5, 6, 7 is followed by, means 1, 3, 4 is followed by 6, 7, 4, 5 is followed by 6, 7. Now we'll see important term from this unit, that is nothing but probability. Many times they ask questions on the probability. So what is meant by probability? So probability is the measure of how likely an event or outcome is. So what is meant by event? So event of, suppose you are flipping the coin. In that case, what is the probability of head event? What is the probability of tail event? If you are flipping two coins at a time, in that case, what is the probability of HH? What is the probability of TT? So this is nothing but the event. So different events have different probabilities. So you can, how do we describe probability? You can describe the probability of an event with the following terms. So these are the different categories of the events. Certain means the event is definitely going to happen, that is called as certain. Likely means the event will probably happen but not definitely. The third category of event is unlikely. The event will probably not happen but it might. And impossible means the event is definitely not going to happen. So these are the different categories of the events. So as per that, the probability is calculated. So probabilities are expressed as a fractions. The numerator is the number of ways the event can occur, and denominator is the number of possible events that could occur. Now see experiment. Experiment means I give an example of flip a coin. That is one experiment, means flipping the coin, single coin. Then flipping two coins, that is another experiment. Then if you see rolling the dice is another experiment. These are the example of some experiments. So what is a random experiment? Is an action or process that leads to one of several possible outcomes. For example, when you experiment, example is flip a coin. In that case, either head or tail will be the outcomes. If you see the exam marks, so exam mark you will get a marks in between 0 to 100, not beyond that. So exam marks, experiment possible outcome or sample space is 0, 1, 2 up to dash 100. Assembly time. So whatever the time, it is always greater than 0 second. Then course grades. Again, it is depends on how many grades are there. So here F, D, C, B, A plus. These are the different outcomes of the courses grades. Now, what is the probability that I will choose a red marble? So you see one example. So choosing the red marble from the given set of marbles. So in this bag of marble there are 3 red marbles, 2 white marbles, 1 purple marbles and 4 green marbles. So what they ask, what is the probability that I will choose a red marble? So red marbles, we know that 3 marbles are available. So in that case, sample space, the set of all possible outcomes. So set of all possible, and what probability is nothing but likelihood of each of the possible outcomes. Always probability is greater than 0, greater than equal to 0 and less than is equal to 1.0. So probability of event. So here event is nothing but probability that I will choose a red marble among the all marbles. So probability of event is greater than equal to 0 and lesser than is equal to 1. So program